Hi, Shiva.
Hi, sir.
So, in today's session, we'll see what is machine learning, mm, data science. So, the day one agenda is difference between data science and machine learning, and we'll use 5 data science use cases, and we'll see data science technical design and up to coding guidelines. This is the agenda for today's topic. So, here first thing is we'll see what is the distinction between data science from machine learning, the key differences and practical use cases we'll see. Okay. So the introduction, if you say, in this presentation, we'll delve into the variances between traditional machine learning and cloud machine learning. Grasping these variations is paramount for effectively utilizing the appropriate tools and methodologies in your projects. Basically, what happens? The concept for data science is different. The machine learning concept is different. Machine learning is coming from AI. Data science is coming from mathematical analysis, statistical analysis kind of background. We'll see what are those. Okay. So here, data science is multidisciplinary domain that employs scientific techniques, algorithms, and systems to derive insights from both structured and unstructured data. We discussed about what is unstructured data, what is structured data. If you take a social media data, that is called unstructured data because there is no rows, columns kind of data formatted it. When data is formatted into rows and columns, it is inserted into the relational database management systems like Oracle or SQL or Mongo, MariaDB, such kind of databases. If it is social media or text-based non-SQL databases, it is inserted into MongoDB, DynamoDB, Cosmos DB, like Azure database, those things. So that is called unstructured data also, and non-SQL data. But in any of these data files, you can have uh, unstructured data. Unstructured means like you can have gaps in the data. Unfilled data will be there. Unfilled columns will be there. Those also can be used for data massaging, data filling, data cleansing, such kind of activities. So the data science amalgamates expertise from statistics, computer science, and domain knowledge to analyze and elucidate intricate data. It means it massages data, it cleans the data, it fills the values into the empty columns, empty cells, such kind of things. It does it. It means basically it prepares the data. Machine learning is a branch of artificial intelligence dedicated to creating algorithms enabling computers to learn from data, make predictions, and identify patterns to inform decision making without explicit programming. If you see the previous slide, data science needs a lot of statistical analysis, a lot of data cleans up activity. But machine learning, what happens? It has got automated algorithms. Those algorithms enable the computers to learn from the given samples. We can give 10 samples, example. With 10 samples, it can create some hundreds of samples or thousands of samples. It can generate dummy data also. Then from there, it can be learning from the predictions. So it make uh, predictions and identify patterns to inform decision making without explicit programming. So we don't need to write much programming here. If you take the data science activities, yes, they do all these things. They write the algorithms with the programming. But here we have built-in algorithms will be there. Those can be used it. Okay. Then key differences overview. The main contrast between data science and ML centers around their respective goals, individual goals. Those are data science focuses on delivering insights and informing decisions, whereas ML is dedicated to developing models for automated predictions. So data science is a like a traditional programming we need to do. ML is it has some kind of model development activity. Once the model is developed with particular algorithms, then that is going to be automated. When it is automated, it can work for the required business requirement. What is the business requirement here? Predictions. So you take a weather forecast. forecasting. Forecasting happens through the predictions only. Next 1 week, next 1 month data, they analyze it and they give the predictions what happens in that particular region kind of thing. According to that, 70 to 90% it is meeting the same way. You can see if rain is there, then it comes rain. If it is sunny, yes, it comes like a sun day kind of thing. So that is called prediction. So with those predictions, we are getting the dashboards in mobile apps, where like weather forecasting through this machine learning algorithms only. Okay, are you getting the difference? Sure.
Sir, hello.
Okay. So data science techniques are what? Data science implies various techniques such as data cleansing, exploratory data analysis, and statistical modeling. What is data cleansing? I told you 2 slides before. There are unfilled data in the rows and columns of the database. Then you need to fill the data. It should not be empty. That is called data cleaning and filling. Okay. Then exploratory data analysis means you have some data file, you need to analyze the data. What you are going to do with your domain knowledge, you are going to explore it. After exploration, you are going to come up with some kind of activities. And statistical modeling. Statistical modeling is like you have variance analysis is there in statistics. Analysis of variance is there. Such kind of unknowable, such kind of things can be prepared. So these methods help in understanding data trends and drawing conclusions that can guide business strategies and decisions. Basically, what happens when you use these kind of methods, you are going to come up with a conclusion, like business conclusion. You take a prediction on particular topic. Customers came to buy online for particular items. You are going to take feedback that you are going to analyze it. If positive feedback is there, you can bring some more items the similar way and host on e-commerce site. That is the indication. With that, what happens? You are designing the business strategies. What is the next strategy? We can bring more items like this because we got very positive feedback from the customers. So that is the strategy, and you are going to take a decision to increase some more items. Right. Next one is machine learning techniques. Common machine learning techniques include supervised learning, unsupervised learning, and reinforcement learning. Each approach serves different purposes such as classification, clustering, or optimizing decisions based on feedback from the environment. Now, if you see, common machine learning techniques are supervised learning. Supervised learning is we give every time sample data, then we are going to run the algorithm and get the outputs. Unsupervised learning is you train the model with algorithm with the databases. Then it is going to work for that. Without supervising, it keeps on running like a automated scripts or automated program. So, and reinforcement learning is like you want to change the model, you want to change some kind of changes in the business strategies or decision making. So, then you need to update the algorithms. Then after updating, you are training that model. Then after training the model, you are going to deploy it, redeploy it. This is all comes under reinforcement learning. So the model is trained and it learned and it trained, it deployed it also. Each approach serves different purposes such as classification. Like you can classify the data into different regions. Let us say weather forecast is there. Total weather forecasting program is one only globally if it is working, or in one country if it is working. But if you take in India, state-wise weather forecasting can be there. Region-wise, within the state, district-wise or region-wise also, forecasting will be there. And surrounding to the Bay Area is seashore areas. How is the weather? What is the prediction? It can predict it. Those are the classifications can be created. Then clustering is like you want to see particular locations for particular monsoons. Okay, now the summer has gone, winter monsoon is coming means there are some states need to be identified. They are coming under winter monsoon clusters. That way you can decide it through the weather forecasting for those areas only. or optimizing decisions based on feedback from the environment. Yes, depends on the environment also. We can feed it to the weather forecasting programs. Those are the algorithms in machine learning. Then through the data also it can predict it. It means basically the predictive analytics is going to be created by the tool. Next one, use case wise. If you see data science use cases, we are seeing firstly. So data science is widely used in fields like healthcare, where it helps analyze patient data to improve treatment outcomes. So you take any hospital. In the hospital, what happens? We go and register as our patient. When we register it, they'll go for they'll write for some tests. So the patient attended test. They're going to see the data from the test reports. After that, they are going to analyze it, and after that, it is going to come up with outcome. Outcome means recommending the treatments. Depends on the symptoms identified from the reports. All this domain data is automated with data science programming itself. So by leveraging statistical analysis and data visualization, organizations can make informed decisions based on comprehensive insights. Means whatever statistical analysis program is done in view of data science approach, it is going to come up with some kind of decisions and the highlights or insights what is happening kind of thing in the patient data. This is one example. Then machine learning use case if you take, in machine learning applications are seen in recommendation systems. Recommendation systems means you take predictive analytics or personalization. All those things they are going to predict some, give some recommendations. So this is the weather forecasting. Now heavy rains are going to fall in next 3 days. That is the report. Some TV channel is broadcasting. Okay, sorry, telecasting. So that way, what happens? We're going to be alerted. It means the machine learning systems work for recommending some kind of actions, such as those used by e-commerce platforms also. E-commerce platforms I discussed on feedback of the customers. We can do a lot of predictive analytics. We can see what we can recommend to that particular customers also. So these systems analyze user behavior to suggest products, enhancing customer experience and driving sales through personalized recommendations. These are the topics we discussed on e-commerce and also weather forecasting also. Then collaboration between fields. Here we have two fields. One is data science, another one is machine learning. How we can collaborate each of them. So while data science and machine learning are distinct, they often collaborate. Data scientists may use machine learning models as part of their analysis to delve deeper insights. So basically, data science people they have to write manually the programming. They need to test it. They need to develop it. They need to apply with sample data. Then after that, they need to release like a model. But that effort is heavy. So when they have a ready-made solution with machine learning algorithms, they will come and use from the machine learning perspective. It means data scientists, people can go to machine learning and use the models. But machine learning people don't need to go to data science because they have already enormous models to automate them. So if they want to, through machine learning models, data science people will interact with them and their analysis to derive deeper insights and demonstrating the interdependence of these two domains. It means they depend on the data. Basically, the ML people need more data. Data science people can supply the data. Data science people need algorithms. They can supply the algorithms to train the model, to test the model also, right? That is where vice versa, it is going to collaborate. What are the challenges in data science? Data science faces challenges such as data quality, scalability, and the need for domain expertise. Domain expertise means if you take social media, we discussed there are 3, 4 popular sites are there. One is X, which means Twitter, Facebook, Instagram, then Pinterest, such kind of things are. Then one need to understand the flow of the data in those sites as a social media marketer. Then that is called domain expertise. So they need to have domain expertise to analyze that data also in the social media. Addressing these issues is essential for successful data-driven decision making and ensuring that insights are actionable and reliable. Yes, those decisions they are going to take it with their domain expertise. So, what are the challenges in machine learning? Machine learning also encounters obstacles, including overfitting, data bias, and the requirements for large data sets. See, if you have a big data kind of setup, there will be millions of records. When millions of records are there, you need to divide them into different data sets. As I discussed with you in the use case of weather forecasting, if you want to do overall analysis for one country, country has got different regions, different locations. Location wise also you can do clustering. So those clustering areas what you identified that need the data to analyze in that locations. Those can be called as data sets also. You're going to divide them into different regions, data sets for weather forecasting, then analyzing that using the ML with algorithms. So understanding these challenges is crucial for developing robust models that generalize well to new data. As obviously, we need to create the robust model to take data into different sets and analyze give the reports. Okay. Now let us jump into data science and ML, 5 unique use cases and their technical design, how it happens in the till the development, from the project planning to development. There are 5 use cases. We are going to use it, and for each use case, we are going to design the business solution. After that, we are going to derive into technical solution design. Then later, we are going to plan for developers to implement the design in the coding. Then after that, we are going to use the coding guidelines. We'll walk through one by one. Yeah. Data science first, we need to understand 5 unique use cases and their technical design. Okay. So first, let us see use cases. Here are 5 diverse use cases of data science. What are those? Just a moment. I will see this one. This is visible, right? Clearly?
Yes, sir.
Okay. Now?
Now it's
Now it
good.
is visible?
Yes, yes.
Okay. Right. So what are the 5 use cases? First one is fraud detection in financial transactions. What are those things? Data science can be used to analyze patterns and anomalies in financial data to detect fraudulent activities and protect against financial losses. Now let us say you have a credit card. If you have a credit card, somebody uses the credit card online. Okay. How they use it, we don't know. Hacker. That is the guy hacker. He hacked the data from browser. That is possible, right? So this fraud, one need to detect it on the financial transaction. For that, you can use data science. This is one example only. Then healthcare predictive analytics. Data science techniques can be applied to analyze patient data and predict diseases outbreaks, patient diagnosis, and treatment outcomes, leading to improved healthcare management and patient care. There are different phases if you see the patient life cycle. One is you are supposed to predict some kind of diseases from the clinical data, whatever tests were done. Okay. Then they're going to analyze with the data science programs and come up with some kind of insights, what we discussed in the earlier slides. Those insights will give some kind of recommendations to outbreak the diseases. Let us say one diabetes guy is there. He has got a lot of issues. Then ultimately, doctors will suggest there is a possibility you are going to get heart attack. Right? If high BP is there, diabetes is high, what happens? Symptoms are more for leading to heart attack. That is the analysis it has done. Now it is going to recommend something to patient. Those recommendations will be diagnosed with it by the doctors and advising the patient for the treatment. Sorry. And treatment outcomes leading to improved healthcare management and patient care. It means totally the patient will get the full solution through the data science and that solution is going to analyze it by the doctors and will advise them with the medication. That is one advantage of data science. Third one is customer churn prediction in telecom. By analyzing customer behavior and usage data, data science can predict the likelihood of customer churn. Let us say you have mobile Airtel. From Airtel you have taken. Another mobile is there with the Geo. Now, in Geo, you are going to buy so many things. In Airtel, you are not going to buy it. So they're going to analyze customer behavior with that. That is called customer churn. What kind of options he is using, what kind of features he is buying. Such kind of things are analyzed and are churning the customer data. So enabling telecom companies to take proactive measures to retain customers. So if you love to buy some other options, some other features from the Airtel or Geo, then they're going to give with discounted options. First month if you buy, you will get free. Second month onwards, you will get billing. Like that they will say. Then what happens? You are going to buy automatically. The same options are going to be given as predictions in the data science, like how it has given to the doctors as recommendations in the healthcare predictive analytics. Here also prediction is there. Then fourth one is demand forecasting in retail. The retail business use data science to analyze sales data, customer demographics, and external factors to forecast demand for products, optimize inventory management, and plan pricing strategies. How it is retail businesses? Each item wise they can sell it. Wholesale is different, retail is different. They use the data science to analyze sales data. Whatever item they sold it, they get the customer data. Then they'll see the customer demographics and they'll see external factors to forecast demand with that customers. Let us say one iPhone is there. The similar to iPhone, Samsung also brought into the market. Then Nokia bought. Then Oppo bought it. All these four products companies they brought equivalent to the iPhone. Now what happens? Whoever bought the iPhone, the guys can buy other phones also, which is cheaper. For example, then you are going to take that customer data and you will give it to data science program and it will analyze it according to the customer visits or feedbacks or purchases. You can recommend this product to this customer like that. It's going to give recommendations, suggestions through that. So then you are going to optimize inventory management also with that. More customer requests are coming means obviously you are going to increase the quantity size available within the store and plan pricing strategies. You can increase the pricing when demand is more. If you see telecom companies also, they increase prices when they have huge customer database. You know how it happened for Geo and how they migrated to BSNL. Why means BSNL is giving cheaper rates with more features. Geo is increasing the rates 20 to 30% like that. So obviously other companies like Airtel also they increase it 12 to 15% in the billing. What happens? They look into other subscriber, obviously. So this is the demand forecasting going to be analyzed. Then here, next one is personalized marketing. Just a moment. Let me. So the personalized marketing is data science models are employed to analyze customer preferences and behaviors, enabling businesses to personalize marketing campaigns and develop recommendation systems for products and services. So we have seen the ML specialized is recommendation system, they use it. Both data science and machine learning uses personalized marketing also for analysis of the data for recommendations also. Here, what it does, data science, data science models are employed to analyze customer preferences and behaviors. By taking the existing customer data, they are going to give the preferences for each customer, enabling businesses to personalize marketing campaigns and develop recommendation systems for production services. Obviously, they're going to use personalized marketing. Each person wise, they're going to recommend this person can buy this item, another person can buy other item. Like that, they're going to give recommendations. Then the data science models. So to improve the business services. So here we discussed about 5 use cases. What we will do? But today we are going to stop it up to this use cases discussion. Then later tomorrow we'll work on the design parts. Okay.